All right, we're on number 2. All right, what are we going to do here? Again, I'm going to kind of talk through it, and I'm going to say I know what x is. X is 6 sine. I'm going to try to take a non-calculus approach. At some point, it'll become impossible. And y is going to be 6 cosine of 5t. So what I'm going to do is I'm going to square both sides, and you get x squared equals 36 sine squared 5t. And you can get y squared is equal to 36 cosine squared 5t. I'm going to add these two equations together. What do you get? X squared plus y squared is 36 sine squared t, 5t, sorry, plus the cosine squared 5t. I know I'm jamming that in there, by the way. So x squared plus y squared is equal to 36. What do I know? This is a circle. Looks like this over here. All right, not so bad. And certainly I know my way around that circle. As a circle is radius r, radius 6, by the way. Forgot to put a square over there. Let me get my ratio because it's not very neat what I put down over there. So it's x squared plus y squared is equal to 36. And the circumference of this circle, let's call it C. And what's C going to be? Let's take a look at it. C will be, let's see, 2 pi r, right? So 2 pi, and what's the r over here? 6. So the circumference of the circle is actually 12 pi. All right? 12 pi. Now, the problem for a lot of students is to just run, how many times is it going around? Well, if you thought about it, and again, I want to point out, I know sort of like the cycle of this thing over here, that, it's 5t equals 2 pi. You get the idea, right? And t equals 2 pi over 5. Right? So it's going to complete a cycle for the sine. Starting at 0, it cycles through to 2 pi over 5. Then the question becomes if you, again, thinking through it, and that's what we're trying to do over here without doing any calculus. We'll get to the calculus later. You'll see the calculus makes it easier for me to think through the problem, by the way. But right now, 2 pi over 5, but I need to get to pi. So I'd have to multiply that by 5 halves. All right, to get to the pi. Now, when I say pi, I see it over here. Whoops, sorry about that. And what's 5 halves times 12 pi? Well, let me write that down for you. 12 pi times 5 halves. Well, that's going to be 6 times 5, which is 30 pi. All right? Kind of expect to see 30 pi in the end of this problem over here. Now, I don't think that's the way to attack the problem, by the way. So what I'll do is, the calculus part. All right, we're done with this. I'm pretty comfortable I'm going to get 30 pi in the end, though. And again, thinking can be difficult. Let's take a look at this. So I'm going to say x equals 6. I'm doing the calculus now. Sine 5t. And the y equals 6 cosine dx dt. You could also write that in x prime with the understanding that x prime means dx dt. What do you get there? Well, you can get 30 cosine of 5t. I'm going to write down dy dt. You could also write down y prime with the understanding that y prime is dy dt. What's that going to be? Minus 30 sine of 5t. Well, let's write our integral down now. I'm going to call it s as the arc length. We're going from 0 to pi. Square root. Well, I got to square these guys over here. It's kind of nasty looking. I'm not going to really do too much work, but 30 squared cosine 5t. I go extend this guy over here. Plus 30 squared, because minus 30 when squared is still going to be 30 squared. Sine squared. Oops, I put a square there. dt. Again, we're still working on this problem over here. Well, I see the 30 squared, I pull it out, square root of 30 squared is 30. And then I'm left with cosine squared plus sine squared of 5t, by the way, and that's going to be 1. So I get this over here, relatively simple integration. What do you get? You get 30t, limit integration from 0 to pi, you get 30 pi. As expected, by the way. Thank you.